Thanks, Grandpa.
Okay. There we are.
Okay. Hi, everybody. Oh, I need to do that. Welcome to the BCMT Reimagining the Teaching and Learning of Fractions first session in our webinar series. We have 3 sessions altogether. Each session should be about an hour. We've got dates there. We will resend a Zoom link ahead of each meeting, and we are recording the sessions. And once we've sorted out how to access those recordings, we will post those on the BCMT website for people to access. So my name's Sue Robinson, and I am here from Salt Spring Island. So before I let Jen introduce herself, I just wanted to acknowledge that I am here on the unceded territory of the Coast Salish people, here on Salt Spring Island, what is known as Salt Spring Island, where I live, play, and learn on the shared territory of Swat, Wasanich, and Cowichan nations, specifically the Hulkaminam and Sinchotlan speaking people who have traveled and fished the waterways of the Salish Sea around us for thousands of years and continue to live on and steward these lands today. I feel really fortunate to live where I am. I've spent the past couple of days traveling from Salt Spring to some of the other islands that are part of the Gulf Islands School District, and it's a pretty amazing place that we live in. And so I'm really fortunate to be able to live in such a beautiful place and get into the ocean as much as I do. I'm going to pass you over to Jen.
Okay, and I'm Jen Carter. I first of all would like to acknowledge that I am here with you from the unceded territory of the Silk people. And that's specifically, I'm from Vernon, Vernon in the Okanagan. And the Silk talk about how we're coming into the time of the buttercups. And that is something that I'm very excited about because I'm fortunate to be able to work in close proximity to our Indigenous lead team, our learning coordinators for our Indigenous department, and have learned a bit about the local plants. And so I've been out hiking, or at least for a walk with my dog Chevy almost every day, and just trying to identify the plants and adding them into my pottery work, which I've been doing for about 15 years. So anyway, happy to be here. I'm a learning coordinator for grades 4 to 12 here in Vernon. I was a numeracy coordinator for about 8 years before that, K to 12. And I've also been doing some work in the past couple of years with Revelstoke and also Penticton school districts. So I saw there are some people here from those districts. So welcome everyone. Thank you for joining us today. And we're just going to start off as part of our introduction with a little bit of like a notice wonder activity. And you can just do this, take part in this by entering into the chat. We have a map here of the travel instructions from Vernon to Salt Spring. So if I was going to visit Sue, my question is to you is, what do you notice? What do you wonder about this provocation? And in terms of thinking about use of fraction language, fraction relationships or concepts, how could you think about this image with that in mind? So go ahead and just, any ideas, enter into the chat. We'll maybe give you like 30 seconds to add some things because we do only have an hour. Long way to Vernon. I was just in Tofino a couple weeks ago, and yeah, it's a bit of a drive to the island. Thinking about ferry time, what is halfway, what's quarter way? So a bit of things about ideas around time, travel time. Where would we meet, in the middle or halfway?
Ooh.
Ratio of
we
water
should do that
travel
sometime.
to land travel. Yeah, we should figure it out.
We could like leave at the same time and see where we meet.
What
And then we'd
fraction
have
of
an
your
answer
trip?
to the question.
Yeah. What fraction of your trip would be on or over water? Great. Couple
Oh,
more.
if you
How
have an
many pit
electric
stops?
car, how far would the battery charge get you? I guess
Yeah.
it depends what kind of car you have.
Yeah. Okay, thanks. That's great, everyone. Yeah, I guess the point of this activity is that we really can present a context to kids and just let them talk. You know, introduce a concept and just let them talk and challenge them to use some of the language or ideas that they know based on their own background knowledge of a math concept, and we can do some formative assessment just from that conversation. That would give you a good sense of where you need to start with your kiddos. All right.
So one of the places that I always start, and I forgot to give a little bit of my background. I teach grades 9 through 12 mathematics here on Salt Spring, but I've also recently started a new position as a district numeracy support person, and I've had a lot of opportunities to work with K-7 teachers along the way, including Jen and Debbie, who I can see on the screen. And so I've learned a lot about teaching math from the teachers that I've worked with from an elementary perspective. And so one of the things that I love to do in my first week of class with my grade 9 students is I want to try to get to know who they are as mathematical thinkers. And I will always do a fraction talk. And so I'm going to do, I'm kind of at a disadvantage here, Jen, because I can only see my screen and I can't, like I'm like 95% sure that the next screen is where I want to be, but we're
Okay.
just going to take a chance here.
And while you're
so,
just doing that, I just want to mention too that I'm more of an elementary background in my past teaching history, and Sue is more secondary. And we came together with the intention of trying to really, for ourselves, learn about the progression of fraction development, and then offer that from our experiences. So, yeah. Anyway, I'm pretty
okay.
sure you're okay
So
with the next slide.
the next slide. Okay. So when I move to the next slide, I'm going to show you a square, and inside that square, there is a pink section. And my question to you is, how much of the entire square does the pink section take up? And really, I just want an estimate. And I want you all to come up with a fractional estimate. What is your estimate? But don't put anything in the chat just yet. And you can get it ready, but don't press enter or return. I guess it's return. And then once I say waterfall, you will all press return at the same time, and we'll see this really kind of fast moving flow of estimates for this particular fraction. So what fraction do you see? And again, we're just starting with an estimate here. Oh, right button. Oh, no, there we go. What fraction do you see? A rough estimate. I'm going to give you 15 seconds think time. And waterfall, throw out your estimates. Okay, so seeing lots of quarters, some 6s, some 8s. 3/16, it's a fairly specific estimate. Got that a couple times. This is my favorite fraction talk. So if you've ever been in a session with me before, you might have seen this fraction in particular. I'm gonna show you another screen, and this time I want you to reconsider your estimate. Was your estimate close? Do you have a better ability to figure out how much of the square is shaded now that I have added in a few lines to help you out? And we probably have a couple of minutes for people to share their thinking about how much is shaded. How do you know?
Yeah. Much less than I thought.
Okay. Does anyone want to share their thinking here? Like come onto the screen and talk a little bit? Get some more 3/16 happening. What? Ooh, 3/4 of 1/4.
That's what I
Is
thought, Naomi.
interesting. Which is a really nice like way to talk about multiplying fractions, like on the very second day of Math 9, just to see what they remember. What's interesting with this question was I've used this for a long time, and for the first couple of times that I used this in my grade 9 class, I noticed that students were talking about 1/7, and other students were talking about 3/16. And it took me a while to figure out what the 1/7 was. And it wasn't that those students were wrong. They were just answering a different question than the one I had imagined I had asked them. So I had always imagined I was asking like how much of the whole is shaded. And then when I started asking them just about what fraction do you see, some of the student responses started to come out like, oh, it's 1/7 because one of the 7 pieces is shaded pink. And that gave me an opportunity to really have rich conversations with my students about the different meanings of fractions, that idea of part to whole versus part to part. And lots of the students had never really heard that terminology before or hadn't really considered what the difference might be. When we teach fractions, we tend to default to part to whole, but that part relationship is really important even as we move into the senior grades, like a concept such as slope. When we're talking about the slope of linear functions, it's a part to part relationship. We're looking at a ratio here. What's the rise over the run? It's not a part to whole fraction at all. And so having that really good understanding of these different kinds of the different meanings of fractions, the different contexts that might come up. Some other contexts might be measurements. We can use fractions to measure a linear distance. We could be half of the way between here and between Salt Spring and Vernon, and where would that halfway place be, and what would that measurement be? We talk about fractions as quotients. So fraction is a division operation. And it's always like, I often feel that secondary teachers are often surprised that students don't understand that a fraction is also a division statement. But unless we're explicitly teaching them that connection, they may not have that robust understanding as they're heading into secondary. A fraction as an operator, so it can be a scalar factor, like half of an amount of something or twice as much. I've got twice as much dessert as my daughter has. Is that really fair? And so as educators, we need to deepen our understanding and knowledge of fractions so that we can help support our students in their learning. Okay, Jen, I can't remember what's next.
The protocol, but Christine mentioned, she said it's easier to visualize this as 3/16 by looking at dividing each quarter into quarters. So I often see that in elementary kids being able to, that being a way for them to start understanding that part to whole relationship.
Yeah, and Darren's asked, is the reason that some students would see 1/7 maybe due to the fact that they would usually see pre-partition shapes and that the pieces are typically the same size. And yes, it could be. In fact, one of the things that's really important is that students have that opportunity to partition objects themselves, that we don't just do that for them, that we aren't constantly giving them shapes that are pre-partitioned. They have that experience of breaking things up. So with this, lots of the fraction talks that I do might be just oral discussions within class, but with this particular one, I give a copy to my students on a piece of paper so that they can start to draw lines and partition. And then I'll invite students to come up to the board and show us how they partitioned, because some of the students, there are a couple of different ways that come up with the partitioning, but sometimes some of the other students are like, oh, I didn't think about doing that. And then they start to impose this grid formation onto future fraction talks. So the next time they see a fraction talk, they have an idea, oh, could I cut this into 4 equal pieces and then 16 equal pieces and so on. Or perhaps the shape is easier to divide into thirds and then into ninths. But having the students have that opportunity to play around with partitioning is really important.
And I would say that when I'm working in elementary, I talk with teachers because often teachers ask me, well, should I give them something to draw on? And in elementary, in the earlier grades, it is really important for kids to develop their visual spatial working memory. And this is a great way to do that, to not give them something to draw with and just let them try to do it in their mind's eye. Research shows that that's something we need to help kids in younger grades develop. So yeah. More
Okay,
simple.
I'm going to go to the
Yeah.
I'm going to go to the next slide and pass it over back to you, Jen. I'm always hitting the wrong button now.
Okay, so this is Fraction Talks is one example of an instructional routine. That one, I think either Sue, you made it, or it's inspired by Nat Banting's work, fractiontalks.com. Sue and I have both, and Debbie as well, have been part of the BC Numeracy Network, and a few years ago we did some work around instructional routines and created some cards on how to use instructional routines in your classroom. And we created this protocol of what a typical instructional routine, like what that talk framework looks like. We may share our slides, I'm guessing, from this, but
yeah.
I find that my teachers find this useful to have on hand just to help guide you through that conversation with your class. I'm just checking the chat here. There were a few more. Okay. Yeah, that was you. Okay.
Yeah, and I use this protocol right through all of with any class, with any group of students that I'm working with. I use it with my grade 12s. So we do we might not do fraction talks in calculus, but we definitely do which one doesn't belong, and we use this as our protocol. And my students understand how it works, and I still give them instructions about it. A lot of what we're talking about today comes from work that's been done by Kathy Bruce out of Ontario. And this summer, I spent a lot of time reading her book that she's written along with Tara Flynn and Shelley Yearley called Rethinking Fractions, 8 Core Concepts to Support Assessment and Learning. And I was so excited reading it this summer because it felt like finally I was starting to understand some of the things that I was starting to do intuitively with my classes, but never really knowing if I was taking the right approach. And so their focus is on, they've come up with these 8 core concepts. And these core concepts have given me a way to think about fractions in terms of like, okay, what is it that the students really need to know? And what are the things that I want to focus on? And the picture with the gears is included because it's really a reminder that this isn't necessarily a linear progression, that the concepts get more complex as we move from concept 1 through to concept 8, but they're working more in a spirally kind of way, that each of these concepts is needed to build understanding. But some of the, like when we talk about adding and subtracting fractions as core concept 7, that's maybe when students will be introduced to to adding and subtracting fractions formally, but they should have had experience with adding and subtractions informally much earlier within some of these other concepts. And I don't know, do you want to? Oh, and the other interesting thing too is that anytime you're teaching fractions, you should be coming back to the beginning. That really, like for me, even in grade 9, when students should have a fairly good understanding of fractions, I should be coming back to this idea of like, hey, let's start with estimating proportions and equally partitioning area, linear, and set models. That the time spent on that at the beginning of the year is going to pay off as we build, as the students build a better conceptual understanding of fractions, so that by the time we get to algorithms that they can put meaning behind what's happening there, that the algorithms themselves don't become meaningless. I don't know, was there anything else, Jen?
I would just add also that I think often we jump to symbolic too quickly in K-9, and if you're looking at these key concepts, you might notice that many of them would need the use of visual models. And what I've noticed, I've been in the past 2 years doing a ton of work with students in grades 5 to 7. And when you start with something like a fraction talk, for instance, or something that's visual or hands-on, the gaps and the misconceptions really surface very quickly, and you can really see that see what you need to jump back to in these core concepts. So Sue is right, like not only just saying, well, I'm going to go back and start with estimating, but watching for these things all the time in everything that you're doing around fractions to gauge where your kids are at.
And I have to say, as a teacher, like a grade 12 math teacher, I'm always like quite astounded by the conversations I have with my students in calculus class about fractions. And I had a conversation with one of my students last spring, and she had to, I think it was something like she had to divide a third by a half. And so I said, well, what's a half of, like, she said, okay, a third divided by a half. And she stopped talking, and she had this look like she was thinking about something. And I watched her and I said, what are you thinking about right now? And she said, well, I'm thinking that, like, I have to multiply by the reciprocal, and the reciprocal of a half is 2. And I stopped her and I said, whoa, hold up here. Like, you've got a third. What is half of a third? Or maybe she was, yeah, or no, I said, I guess she was dividing a third by 2, because I said, what's a half of a third? And she said, it's a 6. I said, well, why was it so hard to divide a third by 2? And so she totally understood, she knew what the algorithm was, but she had no idea what it meant to divide by 2. That she did not see that connection between dividing by 2 and multiplying by a half, and looking at a half of a third as being a 6. And it wasn't until we started talking about it. And I don't know how many times that I've had conversations with my senior students and just said, hey, wait a second, what if you think about this? And they're like, oh, I didn't know that. And so building this, really taking that time to build the conceptual understanding is what we want to be thinking about all the time. A big piece of Kathy's work within this book, Rethinking Fractions, is coming from a visual spatial perspective. And so I've just come up with some pictures here that illustrate each of these core concepts. And so our first fraction talk is an example of where we started to use some estimation. And then we put a grid. This is a typical grid that students would impose upon this fraction talk, and they would see that they could divide the whole into 16 equal pieces. Sometimes students go further and divide it into 32 equal pieces. But that here, like this idea of estimating fractions it gives the students a chance to kind of personalize the situation a little bit. That they're looking at it and creating their own story. Well, this is what I think, and this is why I think it. And so it also gives students an opportunity to engage with fractions as a number, and start with that personal frame of reference. And so again, like just, allowing students to make some decisions about how they're going to partition, and giving them different models to really, we forgot about the paper. But just like for a moment, okay, if you have a piece of paper handy, if you have a pencil, just draw a circle. And how long does it take you to divide your circle into 4 equal pieces? Did you do a good job? And then draw another circle and divide it into fifths. How easy is it to divide a circle into fifths? Try sevenths. Can you divide the circle into sevenths? And so we often start with circles as a way to start partitioning fractions, to partition these areas into equal pieces. Easy with halves, quarters, eighths, sixteenths. But any other fraction is going to be quite challenging to divide equally. And so thinking about, maybe rectangles, maybe squares as a way to get students partitioning fractions.
And Kathy talks about the very first model that kids encounter is the one that they will draw on when they need to, or draw from when they need to use a visual model. And so if we're seeing or working with circle models first, and you often see this in workbooks and textbooks, you see circle examples. As Sue said, they're not so easy to partition. And so maybe consider using an area model or a linear model first instead.
Oh, that wasn't even there. Sorry. The first one, I didn't even see that there was a picture missing on that slide. And so then we move from the estimating and the equal partition into naming and counting fractional amounts. And so the number line on the left-hand side here is been divided into thirds. And so one of the things that Kathy talks about a lot about is counting fractions. So students do experience a lot of counting in the early years. And so we should continue that practice of count alouds and choral counting with fractions. And so what she suggests is counting using unit fractions. So unit fractions really is what should be the foundational piece of everything we do with fractions. And so I wasn't able to write this on my number line, but in terms of counting, we could be counting 1 1/3, 2 1/3, 3 1/3, 4 1/3, 5 1/3, 6 1/3, 7 1/3, and to see that each of these, that we can combine all of these unit fractions. And that's like really early on, like right there, you're adding fractions. So what's 1/3 plus 1/3 is 2/3. Thinking about the count and the unit, and if we're talking about thirds as the unit, and we have fractions with the same unit, then we can look at the count and we can just add the count. So 2/3 plus 3/3 is going to be 5/3. And then on the right-hand side, we just a few pictures here. The core concept 4 is composing and decomposing fractions. So we can take 3/4, pull it apart into quarters. We can reorganize that into 1/2 and 1/4, and see how we can pull apart these fractions and put them together again in different ways. Core concept number 5 is partitioning unit fractions to make smaller unit fractions. So this is really all about density. And so density is something that is quite new to students and can be fairly elusive in early years, that they're coming into fractions from a whole number perspective. And they talked about whole number bias. And so we tend to take what we know about whole numbers and then apply it to fractions. And one of the things that's true about whole numbers is that between every 2 whole numbers, there does not exist any other whole number. But what is true about fractions is that between any 2 fractions, there is an infinite number of fractions. And so we can continue to break these, like take a fraction and break it into smaller fractions. We can partition unit fractions into smaller unit fractions. And we could do that forever if we wanted. And that idea is radically new for students and quite elusive for them. And they need to sort of make sense of that. Following partitioning unit fractions to make smaller fractions, we have comparing fractions. And so these relational rods is a nice visual approach. We can show that 3/9, 1/3, 3/3, 9/9 is all the same as one whole. And so focusing in on some different visual models. We can use visual models for adding, subtracting. So core concept number 7 is as adding and subtracting fractions. And so here we've got, we could, if we were talking about the fractions 1/2 plus 1/8, we can show that on a number line. Students can be looking at that as a way to, using a number line to add fractions. We don't have to move into common denominators straight away. The image, sorry, I just need to move a few things around on my screen. The image on the right is an image I showed my calculus class the other day to try to get them to make sense of 1 divided by 3/2. And so looking at 1, how many 3/2 could we fit into 1? And we can fit 2 of those 3 pieces. And so 1 divided by 3/2 is 2/3. And so using visuals to be able to even multiply and divide fractions. A couple other things that sort of I wanted to touch base on is this idea of like, as you're going through these core concepts and building this deep conceptual understanding of fractions and giving students flexibility, thinking about other ways of doing things. Like we can compare fractions and common denominators. It doesn't have to be the only way we compare fractions. And so if we have this flexibility and we can pull fractions apart, and well, I wish I had an example up here on the screen. I don't know if you have anything there to add, Jen.
Not at the
But
moment.
I think really what I'm trying to get to is like we can get to these the operations on fractions in an informal way much earlier than we need to attend to the formal procedures. And that if we can set up that deep conceptual understanding at the beginning and carry that right on through, the students will be able to put some meaning into the procedures.
Well, yeah, and I've seen many times where I've done a fraction talk with grade 3 and 4 students, and the adding of unit fractions just comes up naturally because they almost need to do it in order to talk about how they see the fraction that they want to talk about and to justify their reasoning. So and the same with using Cuisenaire rods, even Play-Doh. It just, as they rearrange in order to talk about what they want to talk about, they just sort of naturally do it. So yeah, I've definitely seen that early on.
Okay. You know what's coming next, Jen?
I think so.
Okay, because I think I'm passing it over to you for the next bit, right?
Yeah.
Okay. I'm going to proceed through.
Yeah, so I think it's helpful for teachers to know kind of how our curriculum, how fraction concepts progress over our curriculum. Um, it's hard to see, but for grade 3 and 4 and 6, some of the descriptors are in like a dark blue. Those are the elaborations, but I thought they were helpful in order to understand what we are trying to get at for each of these grades. I know that because our curriculum fractions only start to come up in grade 3, I often see grade 3 teachers leave fractions till the end of the school year. So really kids are not getting any exposure to fractions until grade 4. I feel like that's a bit problematic for us, just knowing the work that I've been doing in grades 5 and 6, especially. Ontario fraction concepts or fraction language and concept of half and quarter, I think, come up in either K or grade 1. I've noticed with the classrooms that I've worked with that, first of all, the language of fractions is very complex. And I've noticed that many of our grade 5 students don't have all that language in place yet. And so I think as a grade 3 and 4 teacher, if you can find ways to start using that fraction language right at the beginning of the year and using it all year long, even if you're in gym or you're out on the playground, you know, just starting to use the idea of what is 1/2, what is 1/4, what does that actually mean? Often kids don't even understand that an example of 1/4 could be one of 4 parts. They don't have that. I have to like show them visually what that actually means, because I think what we often see is worksheets where kids are just identifying what half looks like. They know what half looks like, but they don't actually understand what it means. And so then thinking about the core concepts that Sue described, you could look at maybe the grades that you teach and maybe one before and one after, and what core concepts fit in there, which ones are coming up next, which ones maybe happened early on. And yeah, so just some things to consider. We can't just look at our curriculum in grade 5 and jump right away to equivalent fractions, because I guarantee you, and I've seen this many times over the past 2 years, um, students don't have basic fraction concepts in place yet. And so then when you jump to equivalent fractions, it's really difficult for them.
Okay. We've just chosen a couple of quotes to share with you. This was the quote I was going to talk about, my student who couldn't divide a third by 2 easily. But really, like, you know, starting from this visual conceptual model, like fractions are spatial. What do they look like? How do we make use of this? Question here is, do you think children can start learning about fractions even earlier, like K2?
Yeah, so I believe, I feel, just based on what I've experienced working in many different classrooms, is that the earlier that we can start naming examples, different examples of half, what half looks like, what's happening when we create a half or we create a quarter, what's actually happening. I think when we can name that for kids, that's really helpful. And then, like I said, just being explicit with the language of fractions in their everyday daily lives, like finding those examples when you see them happening and name them. I don't think we need to be formally doing fractions in K-2, but I think we really could help kids by naming those examples when we see them taking place.
Yeah, yesterday I was working in a K-5 class. And so Jen, when you talk about the figuring out the concepts for the year before and the year after, I've got teachers in my district who are teaching 5 grades at the same time.
Wow.
And so, you know, we were doing some work with pattern blocks and trying to figure out which blocks were big, like we wanted to organize them from smallest to biggest. And that idea of a half came up because the kids are like, oh yeah, this is like, and somebody said, oh, the blue shape is half of the green shape. And then we were like, oh, wait, are you sure? Is that really what you meant? And then, like, so this, when it comes up, really, you know, use that moment and take advantage of it.
Yeah, Isabel just said my 4-year-old understands if a cookie has been divided in half versus 2 unequal sized pieces. Yeah, definitely. That's a beginning
Yeah.
understanding what fractions are all about, for sure. Thank you for sharing that. And yeah, Cuisinart rods, I agree, super helpful as a visual model for kids. I love this quote by Joe Bowler, that when the same mathematical content is taught visually, it's our experience that the status differences that so often belag our mathematics classrooms disappear. And I really have seen this happen, especially around the idea or the concept of fractions. When kids, I love to give kids just a variety of materials to choose from and ask them to create a model that shows, for instance, 1/4, and label it. And then I can go around and talk with them and ask them, okay, well, which part does the 1 show me? Where's that in your model? What's the 4? What is that? What represents that? What does that number represent? And And kids who, teachers have said, oh, fractions, I think I need to send them down to the learning resource room. Nope. Because if it's visual and they can have some choice in the materials that they're using, are fully capable of representing fractions and starting to talk about them and think about them in different ways.
This
And
is a really
so,
nice video.
oh yeah,
Like
go
to
ahead, Sue.
address like some of that idea, like would K-2 students be able to deal with fractions? And I think this video, I'll let Jen talk a bit more about it, but I think this is the good example to move on from that previous conversation.
Yeah, and so I love Berkeley Everett's website. He has all kinds of visuals of all like, I think pretty much every math concept that's in our curriculum. I don't know, I haven't looked that far into it, but this is just a very simple, Sue, you'll have to start the video, but just a very simple example of how powerful a visual can be for kids. So
Okay,
yeah,
do you want me to start it?
Sure. And this helps helps kids visualize, because we know that some kids can't visualize, and we have to help them create those visuals in their minds and create or strengthen that visual spatial working memory. So this is great for that. Operations with fractions doesn't come up until grade 8, but you can see like we said before, adding unit fractions, our younger kids are fully capable of understanding this. And so there's a video that's maybe 20 seconds long, and then just having a conversation like a number talk. What do you notice? What do you wonder? What's happening in the video? How do you know? What's another way we could show this? So just using prompting questions to get kids to talk. And then you're as a facilitator of that conversation, you're listening for what they know, what they don't know, what language they're using. What do I need to do next to provide as far as like an activity or a provocation or prompt?
I think on the next screen, we have a short task for you all to do. And I forgot to put in the email yesterday that it would be helpful if you had a square piece of paper with you and a long
Or
rectangular strip of paper. So, well, I thought we talked about doing it two different ways. Like if you've got,
yeah.
A rectangular, oh, my screen gets all blurry. A rectangular piece of paper and a square piece of paper, but we didn't send those instructions out. So if you have paper handy, maybe you've got some sticky notes, who knows? We're going to try this next task. We would probably spend a bit more time on it if we were all together in person. It's a little bit hard to do a task. Anyway, I'll move to the next screen here. Okay. Oh, is this one of those? Wait, I've got to move everything around so I can see what's going on.
Because we just want one instruction at a time.
Yeah.
We don't want them all at once. Yeah.
Okay.
So I think I changed.
Are you ready for the first instruction?
Yes. So if you.
Oh, they all came together.
Oh, shoot. Oh, that's okay. This is an activity actually that is part of mathology. If you're familiar with the mathology resource, this is, I think, a grade 5 activity, getting at equivalent fractions. And so you take your paper and you are going to fold it into quarters. You can use a square piece of paper or a rectangular. So you're going to fold it into quarters and then open it up. And then with your pencil, just roughly shade 3/4. And I actually usually have kids somehow label 3/4, or just for them to remember, okay, we've just shaded 3/4, that's what we're dealing with. And then you ask them to fold again to create equivalent fractions. And so I just kind of let them fold how they want and then unfold. And then it's really clear, like we're thinking about how many parts are there all together from the folds and how many of those parts are shaded. And so right away they can they have the equivalent fractions. And then they could fold again. They could keep folding and folding, and then they'll see all the different equivalent fractions that are created from their folds. So you can go ahead and do that.
And I think it would be interesting to do it with different shapes of paper, because how you
Yes.
fold a square might be different than how you fold a rectangle.
Yeah.
I know that if I was folding a square, I would probably fold it in half and then in half again, and probably create some diagonal folds. Whereas with a rectangle, I'm not sure if I would introduce the diagonal folds.
Well, and you just let them, I let them just discover that for
Yeah,
themselves, because then there's the conversation of, do we have equal parts? Why is that important?
yeah. And I like how Kathy Bruce talks about equivalent fractions as renaming fractions. So we're changing the unit when we have an equivalent fraction. So we start with quarters, so our unit is quarters. We're shading 3 of the quarters. When we fold it again, we change the unit. We now have eighths, and we would have 6 of the 1/8 shaded in, and if we fold it again, we would have 16ths, and so our unit keeps changing as we fold, but the fractional amount is still the same. So we have this conservation of quantity, but we're renaming the fraction. And thinking of the denominator as a unit is really helpful when we start adding and subtracting, because you can only add and subtract quantities that have the same unit. And this would be more fun and interactive if we were all in person.
Yeah. Like Sue said, we'd have different types of paper for you.
Yeah. We kind of thought like we would finish up with a couple of activities, so that we will just sort of talk through the next 2 activities. We might not really play around too much. Another folding activity. It's nice to, and Jen, maybe you want to talk a little bit about that hands-on manipulation, folding of paper, particularly in the younger grades, in terms of really giving some concrete thinking behind the fractions.
Yeah, I think, and I sort of mentioned that earlier, just exposing kids to a variety of different materials, not even just paper folding, but I found, and I think the teachers that I was working with thought I was crazy, but bringing in Play-Doh and letting kids cut, like build a shape and then try to cut equally. And we talk about how it's really hard to be super accurate with the cutting, but once we've had that conversation, they know that it's supposed to be equal parts, and just playing around with creating equivalent fractions that way too. It's just, again, I think I mentioned earlier, kids hold on to those initial models that they have experiences with, and then when they're, thinking, doing that visualizing, often those are the models that they go to support their thinking and their reasoning and all of that.
So we just thought we'd sort of stick with the theme of paper folding when we're sharing some tasks today. And so this is a paper folding activity that is available as part of one of the weeks, I think maybe even the very first weeks of inspirational math from UCubed. The original couple of years of weeks of inspirational math are now called classics, which makes me feel kind of old, but that's okay. But this originally came from Mark Driscoll in a geometric thinking textbook. And so you would need some square paper, so always helpful if you've got origami paper on hand. So construct a square with a quarter of the original area, and then some triangles and another square. And there's one of these that the kids, I use this with grade 8s and grade 9s a lot, that is really quite challenging, and kids don't really see a solution quickly. This is a nice task because they can all do the first few, and then they get stuck at different places, but everyone's got an ability to fold the square into triangles with a quarter, or construct a square with exactly a quarter of the area, the kids have no problem with, and they can do the second one. And then they get a little bit stuck when they start having to think about, well, wait, how do we construct that second triangle with a quarter of the area that's different from the first triangle? But there's nice challenges in here, but getting the kids to think about that paper folding and manipulating of those fractions.
Yeah.
And then the next task, did you want to say anything about this one?
No, I can
Okay.
talk about the next one though.
The next one I had never heard of until Jen talked about it when we were planning this. I can't wait to try it next winter.
Yeah,
But
so
go ahead.
I love Joe Bowler's Mindset Mathematics books. They're super inexpensive on Amazon. I think they're like $26 each. You have to drop back a grade. So if you're teaching grade 7, you would want to buy the grade 6, just based on our curriculum. But this is, I think, a lesson out of the grade 5, where kids cut out snowflakes. But you have to be very clear that as they're cutting, that they need to save the pieces. We don't want we don't want to be losing them on the floor. But basically the question is, what fraction of the paper is cut out when you create your snowflake? And so how they figure that out is they take a piece of paper that's the same size as the page they used or that they cut out of, and glue it together. And then on the back, on the solid side, they start in a corner and start gluing the little pieces until they can see how much of that whole piece of paper has been cut away. And so, yeah, it's just another example of a fun way to have kids engaging with fractions. Some other things that I've found helpful for kids kind of in the grade 5, 6 age range, like the clothesline math. And I used to create these elaborate clotheslines where I made cards and handed them out, and then I was in a classroom with a grade 4 teacher, and she just wrote the values on sticky notes, and she drew the clothesline on the whiteboard, and the kids just came up and put the sticky notes up there. And I thought that is such a better way to do a clothesline activity, because she could be really responsive based on what she was seeing her kids doing and saying. Because when it's something that's pre-created and you can't quickly make another card to add to it, it's not quite as responsive. So that's another example. Like I mentioned Play-Doh. There's an old book. I think it's like the Hershey chocolate bar fraction storybook, but you can find it on YouTube. And as the person reads the story, the kids can recreate or like interact with the chocolate bar that they've made out of Play-Doh at their desk while they're listening to the story. And so, yeah, those are just some examples of like the hands-on visual things that I've done. But the Joe Bowler resources have some really excellent lessons in them. And then I think our last slide just is the resources that we referred to in this session. We didn't mention Marion Small, but her little red book, Uncomplicating Fractions, really talks about that progression from K through, I think, grade 8. And so I find that a handy resource just to have on hand when I'm heading into a classroom, just to kind of get a sense of where they should be at in their thinking, what kinds of questions I can ask them. And so, yeah, our next session is going to be on modeling fractions. And the date.
I'll move to that screen in a second, because I just wanted to point out that a lot of the visuals that I created, I did in PolyPad.
Oh, yeah.
And so it's a really great place for virtual manipulatives, but I am using it quite a lot to add to the things that I'm creating.
And Sue mentioned the Kathy Bruce Rethinking Fractions book, there is a free document online called Paying Attention to Fractions that she was a part of originally. Like that's the original research, not the research paper, but they did research and then they created this document for Ontario teachers before the book was written and published. So that's a great resource to go and have a look at and gain a deeper understanding of fraction, these core concepts as well.
And that's it. But I'm going to stop sharing my screen because it's just easier. And then we can open it up if anyone has any questions before we close things up. But yeah, we will be back in about a month. And again, we'll send out a copy. When I send out the link to the next one, I will send a copy of the PowerPoint, just our slides as a PDF, so that if you want to have a look at anything, just try not to send too many emails out.
Awesome.
And people can still sign up too. So if you want to suggest this to anyone and they want to sign up, I'll look again at the Google form that we put out. I think you can access it still through the BCMT webpage. And then I will redo another email. Like if there's more people who've joined, I'll make sure that they're on the next email. So thanks to all of you for giving up an hour of your time at the end of the school day.
Yes, see you Friday, Darren, in Kamloops. Okay, thanks everybody. Oh, there's
I
the mute.
could stop recording.
Oh yeah. And I found the mute all button.